All right, so what I want to do right now is find where each of those four pieces are on the parent graph. And then we're going to talk about the 5 points that we graphed yesterday to make the graph. So these were the 5 points that we used yesterday to make that first cycle. So I also want to point out that this, and you guys will want to add this stuff to your parent graph. That right there, that's one cycle, one period. Okay, of the sine graph. They go up, down, up. They will all have that same look. It doesn't matter how squished together they are, how spread apart they are, whatever the amplitude is, they will all have that same look. They will all have, let me erase this little guy over here. They will all have this. That's the sine graph look for one cycle. Or if it's positive. If it's negative, it will go down, up, down. That's if it's a negative a negative sine graph. So condensed, up, down, up, okay, or spread out. Okay, that's the sine cycle. So we definitely need to recognize what one cycle looks like, because you're going to be asked that on your quiz. It's going to be like, what is the period of this graph? And you're going to have to know when the period stops. It's not when the graph stops, because technically it doesn't. The domain will be negative infinity to infinity. But when we're looking for just one period, that's the look we're looking for. Okay, just the up, down, up, and voila, you have one cycle of sine. So let's start with the period. I'm going to try and color code this stuff the best that I can. So period, look right here. There's the period. It ends at 2 pi. So I'm going to actually call that the end. It's the end of one cycle. Okay, then I'm going to go to the y-intercept. Y-intercept is 0, 0. There's the y-intercept. That is also called the start. That's the start of the period. That's the start of one cycle. So we have our start and our end. Y-intercept gives the start. The period gives the end. And those are 2 of the 5 points. Okay, now I'm going to go with the midline. The midline, right here, running down the middle of your graph, horizontally. That's the midline. And there's actually a proper order for, well, I don't want to say a proper order, but there is an order for graphing all 4 of these things that will actually make it easier for you. Okay. Now, if I'm going too fast, you do need to speak up. Now, the amplitude. The amplitude we see in 2 places in one cycle. We see the amplitude from here to here and from here to here. We see the amplitude from the midline to the max and to the min. So these are your amps. The amplitudes. You can write out amplitudes. I'm not. Okay. Now, we've talked about the star. Are we okay with where we see each of those things on the graph? I'm hoping that's what you guys saw yesterday. And you're sitting there like, yeah, I saw that. Yeah, I saw that. Yep, notice that one. Yes. So one cycle of sine, you start wherever the y-intercept is. So pretend that point is the y-intercept. And if it's a positive sign, you're going to go up around the circle. That's half of the circle. Now it's the bottom half of the circle, and we're back where we started. But because the angle increases as we move around our circle and our angle is stretched out on the x-axis, we don't see this technically as a circle, but it's still the movement around a circle. So up and around the circle, down and back around the circle, that's one cycle. Okay, so this would be your period. So if your period's pi, it's going to end at pi. If your period's 4 pi, it's going to end at 4 pi. If your period is 7 pi, it's going to end at 7 pi. If your period is pi over 4, it's going to end at pi over 4. You will see this super condensed and like really tight together. The smaller the period. The bigger the period, the more stretched out you're going to see your graph. I promise this will make more sense as we graph these, because that will give you a visual of the graph. And so I'm not going to say much more right now, because you will see it more in every single example that we're going to do. And if you still don't get it, then keep asking. Now back to this. So we see where all 4 of those things are, but now it's how do we know where to put the y-intercept? We know where to put the period. Can you tell me about what thing do the period and the y-intercept have in common?
They're both points.
They are both points. What else?
They're both on the same x-axis, 0.
Okay, let's be more specific with that, because it might not always be the x-axis.
They're always at the same midline. They're always on the same midline.
Yes, thank you, Daniel, for helping Michael with that one. They are on the midline. The y-intercept and the period are on the midline. So when we're looking at the sine graph as a parent graph, we do see it as, oh, it's on the x-axis. But we saw yesterday as we had a k, everything shifted up or down. So the midline shifts, so does the y-intercept, so does where the period goes. So we want to make a note. Let me change colors. We want to make a note that the y-intercept and the period are on the midline. Every single time. Those will go on the midline. The midline is actually going to be the very first thing we graph. Then you know where to put and you already know where to put your y-intercept, but having that physical, visible midline helps you know where to put the period point. Okay, give me something else we see. We got 3 more points to discuss. Anything. You guys don't notice anything else about those 3 points we have left? There's no way you guys are going to be the first class in all the years I've been teaching this that does not see this.
Are the amplitudes going to be on the same number but just opposite? Like one is the first one's on 1 and then the other one's on -1?
They will. Every single time. Your amplitudes will always be at opposite sides. Now, they're maybe not always going to be the same number. So let's go away from the same number. Let's talk a little bit different about those amplitudes. Opposite of what?
The midline.
The midline. They are opposite sides of the midline. Now, let's not use the same number. Let's use a different word for number. The same
Absolute value.
The same absolute value. Okay, and in this case, what is the absolute value representing? Do we remember amplitude and what it represents?
The minimum and maximum?
Okay, they will get us the minimum and maximum. And what is that? The radius in our circle. So we need to remember the amplitude is representing the radius of the circle. So when we are identifying the amplitude, yes, we can say it's 1, but we need to be specific that the amplitude is, and I'm going to make a note over here, the amplitude is 1 above and below the midline. If the amplitude was 2, we'd go 2 above and 2 below the midline. Now, before we have more to talk about with those amplitudes, let's go to that last and final point. We've talked about y-intercept, we've talked about the period. So we have addressed, let me mark these off. We've addressed that point, we've addressed that point, and we've partially addressed the amplitude. There's another point left. Tell me about that point. What do we notice?
It's in the middle of one cycle.
It is in the middle of one cycle because it's this point over here on your circle. It's perfectly halfway around the circle, so it has to be in the middle. Now let's be specific about that middle point. Tell me something about that middle point.
It's pi.
It's pi. It won't always be pi though. It's dependent upon the period, but it is pi right now. What else do we notice about this middle point right here?
It divides one cycle into 2.
It's dividing one cycle into 2. What else do we see?
It's on the midline.
It's on the midline. Sometimes you guys can read my thoughts and sometimes most of the time you guys can't. But it's okay. I'm happy that you are reading my thoughts right now. That middle point, it's the middle. It breaks that period into 2 perfectly even pieces and it is on the midline. So this point is the middle on the midline. Super, super important. So I'm going to add an extra note over here. So we have the y-intercept and the period are on the midline. Whoops. Not an I or an L. The middle is on the midline as well. Wow, we can pretty quickly get 3 points out of those 5 if we know the y-intercept and we know the period, which we will know. Now let's go back to the amplitude, the amplitudes, the max and the mins. Let's look at those. Where are the amplitudes occurring?
before and after pi.
Okay, before and after pi. And pi, you guys said, is the middle. Okay, so the amplitude, one amplitude is before the middle and one amplitude is after the middle. Now let's be more specific with that. A little more accurate about where they are. It's all about location. Location, location, location.
Where it curves?
Okay, where it curves. So the amplitude is what is making it curve. So how do we know where to put the amplitude so we get that curve?
They're your highest and lowest point.
Okay, again, how do we know where to put them? I know the amplitude's 1. How would I know where to put them, though? Why can't I just say, let's put it right here?
Wouldn't you need a negative to put it over there?
We would need a negative to put it over there. So how do I know to put it at exactly that point? How do I know it exactly goes right here?
Because if the radius is 1, then you have to look on your trig chart, which it would be, what is it, pi over 2 and then 3 pi over 2.
Okay. Now what if our period is not pi anymore, or 2 pi? What if our period has changed and we can no longer rely on that circle? Can no longer rely on our trig chart? How do we know that those are the specific spots that they go in? Let me go to a grid that has no numbers.
Is it just because they're exactly in the middle of the midline and the period?
Is it because they're exactly in the middle? So, exactly in the middle. This is the cycle. I didn't even need numbers for this to make a cycle. Because I said, okay, I have my y-intercept, the start. I'm going to go ahead and make that one the period. So I know where it ends. Then you guys told me the middle point was also on the midline with those two. So I was like, okay, I found the middle. And then Michael says, well, because they happen at exactly the middle of those other spots. Is this exactly the middle right here? Did I put that in the middle? Well, the best I could.
Yeah.
Yeah, that's the middle. That was the middle, the best I could get it. So why do I know that that's where I need to put those points? Why do I know that those occur at the exact middle of each of those pieces? Oh, wrong button. That one. Let me use it on here. Here's our circle. It has everything to do with the circle. This is your start, the y-intercept. This is your end, the period. Now we've gone halfway around the circle. Halfway around. And look, we're back on that same axis. That's the middle. So this was the start. This was the end. This is the middle. So what about this circle says, put the amplitude at exactly halfway through that blue highlighted piece that I have.
The y-intercept?
The y-intercept? Say that again.
The middle of the circle.
The middle of the circle is right here.
Oh.
So middle of what?
So the y-intercept, like the actual middle of the circle.
You're saying right here?
Yeah.
The center of the circle? Not necessarily, but it has something, I guess you can say, to do with the center of the circle. What does amplitude represent again?
The radius.
The radius. So we see... Jesus, we're going to say something?
So then that means the circle is the radius equals 1?
So in this case, the radius does equal 1. How do we know to put the radius of 1? Why don't we put it over here? That's a radius of 1. Why don't we put it over here? That's a radius of 1. Why are we showing the amplitude at exactly half? Let me go back up here. Why are we showing the amplitude at exactly halfway through that piece? Why is that the highest point on our graph?
Is it possibly because it marks the end of the first sector?
Is it possibly that it marks the end of the first sector? We're getting a little closer. Be more specific with what you mean by the first sector.
The start up to 90 degrees of the circle.
Up to 90 degrees. Okay.
Yeah.
Now, what happens when I pass 90 degrees? So I started, let me get rid of all these colors. So we're starting here. We're going up and up and up and up and up and up and up. So then Aiden said when we get to that 90 degrees, once we get to that 90 degrees, now what am I doing?
You're going down.
Going back down to
Going back down.
So the highest point.
It's the highest point. The highest point is happening, as Aiden is saying, after that first sector, that first 90 degrees, that is our maximum. We are finally at the highest point on the circle. Now I keep going around and around and around and around. So at here I was back at the midline. I was back at the middle. The same level as the start. But now I keep going down and down and down. And what do I hit when I get here? Is that the highest part of the circle?
it's the lowest point.
It's the lowest point. And where is it occurring? If I look at just this half of the circle, where does it occur?
The middle.
The middle. It occurs directly in the middle. And if we were to go backwards on a negative graph and we start here at the bottom, we go down to the lowest point. and then we work our way back up. The amplitudes represent the max and min. The amplitudes represent that distance from 0, the center, because it is your radius. But we also need to connect the sine graph is the movement around this specific circle. And so we also need to recognize it is that we're going up, 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 up to the top, the max, down, 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 back to the middle, and then down, down, down to the minimum, up, 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 back to the middle. It's literally, you guys, graphing the movement around the circle. That's what makes the sine graph so wonderfully easy. It is the visual movement of this circle. Cosine's not quite that way, but sine is. And it makes this so much easier if we can have that visual piece of graphing sine. So, whoops, I didn't mean to hit that button. So I'm going to go back to this. And you might want to make a note somewhere that this is, I'm just going to go with what classes have said in the past, middle of the middle. Same with this one. Last year they called them the moms, middle of the middle. And that's how they abbreviated it. You guys are welcome to do that. I had never heard that until last year. Other classes just like, oh, it's the middle of the middle. So whatever makes sense to you, the amplitudes are always at the middle. And we also need to remember that they're above and below the midline, not the x-axis. Above and below the midline. So we're going to go graph now. It is time. Now it gets easier. The hard stuff is over, I promise. That was like pulling teeth. Here we go.
Wait, Miss Figgus?
Yep.
What about theta?
What
How
about
does that,
theta?
Because I saw it like on the equations for the homework, so how would you be, would theta just be the x-axis and that's it?
Yes, theta is x.
Oh, okay.
Theta is the same as x. But they're using theta because it is the theta axis. Yes.
Okay.
All right, here we go. So we're going to graph this first one. And I told you guys yesterday to have your graphs ready. I am not waiting for you other than to write the problem down. You guys were actually told on Friday to have graphs ready. So we're going to graph y equals 2 sine of x. You want to list those 4 things first. Even though it doesn't say find those 4 things, you need to find those 4 things to be able to graph this. And it's really good practice for your quiz on Monday. So we want to start by identifying the amplitude, the period, and the order you do this, midline, y-intercept, it makes no difference to me. The order in which you graph, it does matter. Now, if you guys need to put in, if you have your coordinate plane, that's fine. If you need to put in numbers, you can do that really fast. But, and you'll see some of mine are actually blank. I left mine blank so you guys can see how we would decide where to put what if you have a blank coordinate plane. Because sometimes this one that I have here is not going to be big enough. This one's only for an amplitude of 2 if the midline is at 0. So as k changes, then I'm going to need a bigger coordinate plane. So sometimes numbers have to be changed. Go ahead and list your amplitude, period, midline, and y-intercept, please. I'm going to go ahead and do that. Amplitude is 2. Period is 2 pi. Midline is y equals 0. And the y-intercept is 0, 0. Are there any questions on those 4 things? Thank you. All right. So now let's graph. You might want some colors. It actually makes a difference. Maybe a highlighter. So when we're graphing, the first thing you want to graph is the midline. Very first thing you want to graph. Let's get our midline on there. And I usually just use a highlighter for the midline. So this is the first thing we're going to graph. Right here. Number 1. Numero uno. Super important. Okay, so midline. I don't need it that big. Got my midline. Are we okay with graphing the midline? You might want to label that as the midline. If you're not going to remember how to graph the midline, you should though. We all should know how to graph a horizontal line. The second thing you are going to want to graph, you're going to do two things at once. You're going to graph the y-intercept and the period on the midline. That's why you want the midline on there first. Okay, so the y-intercept and the period go on the midline. The y-intercept, 0, 0. Are we okay so far? Please tell me to slow down if you need me to.
Can you hold on for like a minute?
Okay. If it's because we didn't have a coordinate plane drawn, you guys, that's kind of on you. That's really going to grind my gears right now.
Okay, you can go already if you want.
Thank you. Yeah, those of you guys, if we were in class and you guys were taking your time making your coordinate planes, I would not be waiting for you. Because that would be your choice to be going really slow making your coordinate planes. Just like it was your choice to not be prepared. Or you guys were told on Tuesday. Sorry, I said Friday. That day off is throwing me off. You guys were told on Tuesday you were going to need coordinate planes. You guys were told yesterday you were going to need coordinate planes and to have them ready. That I was not going to wait for you. So I'm not going to wait. Okay? I'm done waiting. I'm only going to go as slow as I need to for the work that you should be writing down. So the next thing, the y-intercept and the period are the next two pieces. So y-intercept is 0, 0. Now the period. You go along the midline. So I'm going to go along the midline. And once you hit the period, which in this case is 2 pi, you're going to put a point on that spot on the midline. The third thing you're going to do is you're going to plot the middle on the midline. So you find the middle.
Should we call it the midpoint versus?
You can call it the midpoint if you want to, because it is a midpoint of those 2 points.
Okay, thank you.
And it's really easy, you guys, to find that midpoint. You count the spaces. 1, 2, 3, 4. Oh, 4 divided by 2, because it's the middle, is 2. 1, 2. There's your midpoint. Pretty simple finding the middle. Now the fourth thing you're going to do is the amplitudes. And we need to remember these are the middles again. Okay, middle of middle. However you guys want to word that. You guys, whatever works best for you. We need to remember that they are the radius. The radius is 2. It is the distance from the midline. And since this was a positive 2 at the beginning, that means we're going to go to the middle. So you find the middle of the middles. Okay, so there's the middle of the middles. And we are going to go, since the amplitude is 2, 2 up, 2 down. And there is one cycle of sine. Now you just have to do the one on the back side, the negative. What's really nice with this, in 6.3 we talked about how sine is an odd function. This is a big major note right now. Sine of theta is odd. Therefore, it is symmetric to the origin. I can use that to do the rest of the graph. Going forward, it's really easy to follow that pattern. Going backwards, it might not be so easy. So symmetric to the origin means everything is going to flip around when we graph the left side. Please watch first before you do the graph. Just watch how I'm going to do this. So everything is going to flip around because it's negative and it's, well, sine is odd. So at pi over 2, we went up 2. So at negative pi over 2, we're going to go down 2. Now the 2 points on the midline, they're going to stay. So I'm going to go ahead and put those in. And then at 3 pi over 2, we went down 2. So at negative 3 pi over 2, we're going to go up 2. Those pieces switch. And if when you have drawn this and you look back and your graph does not have symmetry to it, you did something so wrong. Go ahead and draw that. And that's the sine graph. That one is done.
So when doing the graphs, you have to do both positive and negative?
Mm-hmm.
Okay.
I would appreciate that, please. Now you guys are getting more practice recognizing cycles and that the sine graph is continuous. You guys are getting away with a whole lot with distance learning. If I gave you this coordinate plane on a quiz or a test in class and that was all you gave me, was that right there, you'd get a 2 out of 4 for the graph. You would not get more than 50% on that graph because you hadn't finished it. Now, a mistake that I see students make on this, can you guys please look at the screen? A mistake that I see students make is they actually just copy this over. They're like, oh, pi over 2, up 2, negative 3 pi over 2, down 2. And then they do a graph that looks like this. That does not look like any sine graph I've ever seen. So we want to be very, very careful. You need that smooth, continuous curve. Now it's not even a smooth curve because you have this joint right here. Not okay. You guys need me to put the other graph back? You guys good? I'll just draw it. Doesn't take that long. Any questions? I would like to get the other 4 done. We should be able to. Okay, let's move on. Here's the next one. Go ahead and write the equation down. Y equals negative sine of 2x plus 1. I'll give you 1 minute to identify amplitude, period, y-intercept, midline. All right, what's the amplitude?
1.
Thank you for saying 1 and not -1. That just made my day. Period. Thank you. Period is pi. The 2's cancel. What is the y-intercept? Thank you. And the midline? Y equals 1. All right. If you think you are good to graph this, go ahead and start graphing it. Otherwise, I'm going to go over this slowly. So again, the first step is, I'm not going to rewrite the steps. The first step is to graph what?
The midline.
The midline. So let's go ahead and get the midline there. Are we good?
Should be on 1.
Ah, it should be on 1. Somebody was paying attention. This is a very common mistake, you guys. Everyone just will be like, I'm going to put it on 0. Pay attention to what the actual midline is, you guys. So we do want to make sure that midline is on 1. Now what? Okay, yeah, the y-intercept, which is 0, 1 on the midline. And it naturally goes right on the midline, you guys. It's very nice. What about the period? Tell me when to stop. Okay, you see my cursor? Tell me when to stop. Okay. Period's at pi. That's where it ends. That means this sine graph is going to be more condensed. We're going to have more cycles that we're going to have to draw. Now what? Look at the steps. The middle on the midline. So it's easier to find the middle when it's just 2 boxes. Middle on the midline. Now what?
Your amplitude's 1 away from the midline.
Yeah, so our amplitude is 1, and they need to be 1 away from the midline. So where do I go for my amplitudes? How do we know?
The y-intercept and midpoint.
Between the y-intercept and the midpoint. So you got to find that middle, you guys. You just need to eyeball those. Eyeball the middle the best you can. The middle of the middles. I'm not looking for like perfect precision, but something decent. Okay, so then now I can do my amplitude. Okay, my amplitude is 1. So 1, 1. Are we good?
Wouldn't you start going down since it's negative?
We would. Thank you for catching that. So instead of going up first, we actually have to go down first, down 1, and then we go to the next one and we go up 1. That is one cycle of sine. Now you just need to continue it, and you just follow that pattern. So another period, halfway, down 1, up 1. Then when you get to the end, put your arrow, and then reflect them about the origin on the other one. So instead of, period, middle. Now instead of down first, we're going to go up first and then down. And you guys can put all your points at one time if you want, or you guys can go one cycle at a time like I am doing. It is completely up to you. Another cycle, middle, up, down. That is another cycle of sine. Are there any questions on this graph? Follow the list. Midline, y-intercept, period, middle point, amplitudes. Questions? There's not a lot of work with these. They really are nice things to graph. Here's the next one. Notice how my coordinate plane doesn't have any numbers this time. Yours might, and that is fine. I would like you to identify amplitude, period, y-intercept, midline. All right, what's the amplitude? Thank you. What's the period? It is 4 pi. Thank you. Your divide. I'm not going over this, you guys, because this was on your homework last night, how to find these 4 things, and you had fractions. So you guys had office hours that you could have been coming into to get help for those 4 things. And if you still don't understand how to find those 4 things, office hours today. Y-intercept.
0 and -1.
Thank you. And the midline.
Y equals -1.
Thank you. Oh, I forgot the negative. Okay, that one was not on purpose. All right. You guys, okay. Now, the reason I did not put the numbers on this one is because the period was 4 pi. That means this is going to be extended out really, really far. And I don't even know if I were to keep with the same scale that I have here, that every 2 boxes is pi, that I would have enough. Because this would be extended out really, really far. So this is where you guys have freedom to scale your graph, just like any other graph. Sometimes we have to scale the x and the y axes. It's the same here. You guys can scale your graph. The only thing is if you scale it so small, you don't get to see that stretch. If I were to stick, don't write this, if I were to stick with every 2 boxes is a pi, I don't have enough room on here to get all the way out to 4 pi. I'd barely reach 4 pi somewhere out here. Okay, so then it's like, maybe I need to change where I put 4 pi. And maybe you shift everything so, and if you have plenty of room, go every 2 boxes is 4 pi. Then you really get to see that stretch that is occurring with a period of 4 pi. If you don't have room, then you probably want to go where every 1 box is pi. Your choice. I am actually going to stick with every 2 boxes is pi. So 2 pi, 3 pi, and somewhere out here is 4 pi. I will make it work. And then I'll go on the negative side, negative pi, negative 2 pi. Oh man, I have more on the left or the right side than the left side. That is okay. So you guys are going to get to see how you would just draw a portion of a cycle. So this is probably a good thing. So whatever you guys have, you go with it. If your graph is big enough already that it has 4 pi, then you're good to go. And I'm going to leave my y-axis the way it is, so I'm not going to change the scale of my y-axis. And technically, I didn't change the scale of this graph either. Every 4 boxes is 2 pi. Now I'm going to go ahead and put in my midline, which is -1. Did I give everybody enough time to scale their graph? Okay. So we have our midline. Now I'm going to go ahead and put in the y-intercept, which is 0, 1. And the period, so I run along that, and the period is 4 pi. This is why I don't need to worry that I don't have that line extending all the way, because I can draw out my midline so it extends all the way. So I just guesstimate. I probably went out a little too far for that point, but good enough. So now where would the middle point be? Where does that occur? Thank you, 2 pi. And be careful, because I see students every year who accidentally put the middle on the x-axis. They don't put it on the midline. So be very, very careful with that, you guys. Attend to precision. Now it's the amplitude. The amplitude is 3, and it was a positive 3 to start. So we go to the middle of the middles. And again, you need to be careful here, because some of you are going to be like, oh, I'm going to start on the x-axis, because we're so close to the x-axis. You're going to be like, oh, okay, I'm going to start here at pi, 1, 2, 3. And you actually are now graphing an amplitude of 4. But then on this other side, you're going to go 1, 2, 3. Now you're going to have a lopsided graph with no symmetry. So we want to be very careful, attend to precision. You are counting from the midline. 1, 2, 3. 1, 2, 3. And there is your period of 4 pi. The sucker is so stretched out. So slow. Because one cycle would be whatever 4 pi is on a circle of radius 3. So don't think of that as being 2 times around the circle. It's not, because the radius is now 3. It's something different. Bigger the radius, the bigger the circle. Now to go backwards, 2 pi. 4 pi is going to be somewhere over here. I'm not going to worry about that. Instead of going up 3, we're going to go down 3 and then up 3. Now that was at 3 pi. So 1, 2, 3 at 3 pi. So this is how I'm going to graph this, because that got cut off there. And you just put an arrow. You don't have to graph the full cycle. Just graph whatever your graph allows you to graph. Any questions here? Okay, one more. I'm going to let you guys work on this one. Let's see what you can do with this. Actually, no, let's do this one. Let's see what you guys can do with this one. If you want, go ahead and write down D as well, because you guys can work on that one and check in Desmos to see if you got it or not. But I'm going to give you time. And when you are done, check in Desmos right now and see if you got it. Okay, I'm going to start graphing this now because we're getting short on time. Let me do my scale. I generally will do every pi is 2 squares, you guys, no matter what the period is. That's just generally what I do. You guys can decide what you want to do. Okay, so I have my scale. My midline is at 2. My y-intercept is 0, 2. Period is 2 pi. All right, so I got that. Middle point on the midline. Once you get the hang of this, you guys, graphing is actually very quick for sine. It is for cosine as well. I don't want to scare you from cosine. Middle of the middles, amplitude is 3, but it's a negative 3 for the sine. So down 3, middle, up 3. There's one cycle. Check to see if you have this cycle correct, you guys. And then continue the cycle until you're out of room. I'm out of room. That's close enough to being out of room. Continue the cycle. Look for those patterns, you guys. Up, down, up, down, up, down. And that's what you should have. Are there any questions on the sine graph? Can I show you D real quick? Yes, I will show D real quick. Those of you, let me pause this video, be done with it. Okay, so for D, our amplitude is 1. Our period, what'd you get for the period, Christian? It is pi over 2. So really tiny period. The y-intercept is 0, negative 2. And the midline is y equals negative 2. So I'm going to stick with my normal pi, 2 pi. Actually, I remember why I used this one and not the other one. 3 pi, because that midline. Pi, negative 2 pi, 3 pi. Okay, so my midline is negative 2. And now I'm going to start graphing all my points. So my y-intercept is negative 2, but the period is pi. So you guys are going to have to be very, very, very careful with this one because one whole cycle has to be done within that little itty bitty tiny space. So you're not lucky like I am where I can zoom in on this. So you guys are going to do the best you can on your paper. You find the middle. Okay, but you might want to use smaller points, very small points. You find the middle. And then our amplitude was 1. And was it a positive 1? Please stop moving. Yes, it was. So now it's the middle of the middle. Go up 1. Middle of the middle. Go down 1. And that is one little itty bitty cycle. Sorry, I can't help but talk like that when it's a little itty bitty guy. And then you guys would just continue that through however big your graph paper is. So into the cycle, up 1, down 1. Little itty bitty guy. Okay.
Is this part of the homework?
What do you mean is this? Your homework is graphing.
From A to B, is this like part of the homework?
No, they're not from your homework. No. You got to do all the ones on your homework tonight. Lucky you guys.
See you on Monday.
Tuesday.
Tuesday. Oh yeah.
Yeah.